Welcome to this week's video. Today we're going to be doing a LeetCode problem, and I picked this one for us to do. That's called replace the substring for balanced string. That's problem number 1234. It's a medium problem and it has to do with arrays. So let's read now the description of the problem and see how we can solve this. So here it says we're given a string S of length n containing only 4 kinds of characters: Q, W, E, and R. A string is said to be balanced if each of its characters appears n over 4 times, where n is the length of the string. Return the minimum length of the substring that can be replaced with any other string of the same length to make S balanced. If S is already balanced, then return 0. So let's look at the examples. We have here QWER. In this case, the answer is 0. That is because this string is already balanced. We're going to be given a string, and it's only going to have the Q, W, E, and R characters. And we're asked to check whether each character appears n over 4 times. In this case here, n is 4. So 4 divided by 4 is 1. So the expected amount of times that each character should appear is 1. And here, indeed, each character appears only 1 time, right? Now let's look at this other example here. We see here that it's also a length 4 string. We have 4 things in it. And the expected amount of characters to appear is 1. Each character should appear only once. But that's not the case here, because with Q, we see that we have 2 of them. And so to make this string balanced, we would need to change 1 character. We need to replace this Q or this Q over here to a R. And if we replace either of these to an R, then it becomes balanced again. We have 1 of each. Similar here with this other string. We have here QQQW. It's also has length 4, which means each character should appear only once. But here, to make this string balanced, we need to replace 2 characters. And that's why the answer is 2. We need to replace 1 Q to an R and another Q to an E. In each case, we have each character appearing once, right? And looking at the constraints here, we can see some interesting things. Well, n must be a multiple of 4, right? So the input string is always going to be 4, 8, 12, 16, and so on, which means we can always divide it by 4. So we always have a nice number for the frequency of each character. And S is only going to have Q, W, E, and R in it, right? And so to solve this problem here, we can, well, first of all, start by defining some variables here that are going to be useful for us. First of all, I always like to define n to be the length of our input string, length of S. And we can do here a expected frequency variable. So expected frequency, that's going to be n over 4, right? So if S has length 4, each character is supposed to appear once. If S has length 8, each character is supposed to appear twice, 8 over 4, right? And let me switch here now to a presentation here that I did to kind of show better my intuition for this problem and how we can use the sliding window technique to solve this. So here I got a example string, and you see here, differently than the previous ones, this one has actually length 8. It has 8 characters in it, which means the expected frequency of each character is going to be 2, 8 divided by 4. So that means that we need to change this string somehow so that in the end we have 2 Qs, 2 Es, 2 Rs, and 2 Ws, right? And right now that is not the case. We need to find which substring of this input string here we need to change to make it valid, and it's asking for the smallest substring. What's the smallest substring here? And substring is a continuous sequence of elements. What's the smallest substring that I can find so that if I change that to whatever I want, I can make the substring valid again, right? And we're going to be using a sliding window technique here. But what's interesting about this problem is that we're going to be looking at stuff outside of a window. We're still going to have a window that's expanding and shrinking, but we're actually looking at whatever is outside of it. So let me show you how that works. So we have here in red, that's going to be representing my my window, right? And what I'm gonna do here is I'm always gonna be looking at what's outside of it. And I'm gonna be looking for whether what's outside of it is valid. And I'm gonna call something valid if the maximum amount of times a certain letter occurs is less or equal than what we expect. In this case here, it's 2. We expect each letter to appear twice because the entire string has length 8. And 8 divided by 4 is 2. And we can see here right away that this is not the case. This is not the case because we have here R appearing 3 times. So what's outside of the window is invalid. Why is it invalid? Because no matter how much I change what's inside of my window, I can never make this whole string here valid again. Because I have 3 R's here, it doesn't matter if I change this Q to a E, to a W, to another R, it doesn't matter. I'm always gonna have 3 R's. And because I have 3 R's, this is never gonna be valid, right? So what I'm gonna do here, I'm gonna be expanding this window one by one to the right until what's outside of the window becomes valid. In this case here, right now I have Q, Q, and E in my window, but what's outside is still invalid. I still have 3 R's over here. So I keep doing the process, right? I expand it to the right. And once I go to this position here, then I suddenly have something that is valid. What's outside of my window here it's suddenly okay, because now the maximum frequency of each character is less or equal than 2, which was what I was expecting. I have 2 R's, 1 W, and 1 Q, which means I can now change this substring over here however much I want to make the final string valid. And now I have power over it. Now I can actually do something about it. Why is that? Because I have 2 R's here. What I'm missing is 2 E's, I'm missing 1 W, and I'm missing 1 Q. And that's fine. I can change this to whatever I want to make this fit. So for example, I can change this R here to 1 E, right? That gives me already 2 E's that I needed. And now I'm missing 1 W and 1 Q, right? So 1 Q I already have. If I change this Q to a W, suddenly now I have 2 R's, I have 2 Q's, 2 E's, and 2 W's, and I have everything that I need. Now, this does not guarantee that I have the smallest substring. I have a substring that could work, which is this QQR of length 4, but it does not guarantee that's the smallest one. Maybe there's a smaller one that can solve the problem, right? And what I do now to find the smallest one is to start shrinking that window from the left. So I'm gonna do the same process, but now from the left. I'm gonna be sliding this one by one to the left. And the same thing, I'll be checking outside to see whether this is valid. If it is valid, it's the same thing. It means that I found a substring that I can change it to whatever I want to make sure that it works. So let's say I'm here now, I shrunk the substring a little bit, and you can see it's still valid. I have 2 R's here, I have 2 Q's, and I have 1 W. So the maximum frequency is 2 because I have 2 R's and 2 Q's, and that's less or equal than expected, which was 2. Which means then I'm only missing now a E. I'm missing 2 E's and 1 W. That's what I need, right? And so here I can transform this R into a W and this Q into an E, and now I have 2 E's and 1 W. So this is a smaller string than the previous one that also works. So this one would overtake the other one, and this will become my answer so far. And I keep doing this process until suddenly my outer window doesn't work anymore, which is this case here, because now I have 3 Q's, which is now greater than 2. So this is not a solution anymore. I need to start expanding my window again. And I keep doing this whole process again, right? Expanding on the right until it becomes valid. Once it becomes valid, I shrink until it's not valid anymore. So I'll keep expanding this here until I would reach this Q, and suddenly what's outside is valid again, and this becomes a possible solution, but this is bigger than what we had before, so we're not going to be using that, but we can keep shrinking this from the left and trying to see if that's going to work. That's the logic. Now let's look at the code itself. So the first thing that I need to do here is to actually define a dictionary that's going to be holding the frequency of each letter on my outside window, right? On what's outside. And at first, I'm just going to count everything that's in it. Everything is outside of the window at this point in time. So I'm going to simply be defining this as a dictionary in Python. I'm using default dict. That's a way to define a dictionary, and it initializes things for you, so it's easier. You don't have to define a initial value if it's not present in the dictionary yet, but it's a dictionary. And I'm gonna first, go over my array. So for letter in S, I'm just gonna increment my dictionary at that letter by 1. Plus or equals 1. So that's just a dictionary that's holding the frequency of each letter initially, right? And so I'm going to have n here that's going to be holding how many times a certain letter appears on my input string. And there's a one edge case here that we can right away return, and that is when the maximum frequency in general of that string is already what we expect. So if we do here, if the maximum of m.values, that's just retrieving the values of my dictionary. The keys are the letters and the values are the frequencies, how many times they're appearing. So if the maximum frequency in general of my string that's equal to what I expect, that must imply that that's a valid string. So I can return 0 because I don't have to change anything. That's already a valid string. Why is that? Because let's say I have a string that has 8 characters in it, right? I'm expecting each character to appear twice because it's 8 divided by 4. I'm checking here whether if the maximum frequency in general of the string is 2. If it is 2, it must be valid because first of all, no other character can be more than 2 because I'm checking here that the maximum is 2, so there cannot be anything that has 3. And if anything would have less, let's say one of the letters has 1 instead of 2, it must imply that for that to happen, other letter must have more than 2 to compensate for this 1, right? So let's say, the maximum frequency of my characters here is 2. All of the other ones also need to be 2, because if any one of those were less than 2, it must imply that something has to be greater to make up for what's missing. And it cannot be greater because we just checked here that the maximum is 2. I hope that makes sense. But anyways, we're now gonna just do our sliding window algorithm. For that, we usually define a left pointer. I'm gonna initialize it to 0. That's the beginning of our string. And we're gonna be defining our answer here. Answer is gonna be in the end, the smallest substring, the smallest length of a substring you can find that can make our total string valid. And whenever we're finding the minimum of something, usually we initialize the answer to a very big number, or in Python you can initialize it to infinity. So we can do floats of inf. That's a trick here in Python to initialize something to infinity. And whenever we find something that's less than infinity, we update it. So everything's gonna be less than infinity, so it's a good trick to update our answer. And now we can start our algorithm here of the sliding window. So we're gonna be defining a variable right, which is gonna be looping on our through our array. And so for right in range n, the window is gonna be in between left and right. And whatever's outside of it is what we're gonna be tracking with our m dictionary. So right now, right is pointing at index 0, which means you gotta remove whichever letter is at index 0. We're gonna subtract 1 from the frequency of that letter, right? Because now it's not outside anymore, it's inside the window. So for that we do m of s of right. So whichever letter in our dictionary corresponds to our window, we're gonna subtract 1 here. And now we need to track what's outside of the window. We need to check if what's outside of our window is valid, right? And M, again, represents what's outside of our window. So here we can check, right, what's outside of it. So we're gonna do here a while, and we're gonna be saying while what's outside of the window is valid. And how do we do that? We do while the maximum of m.values is less or equal than the expected frequency. While that is the case, we know that we can change our current window to something that's gonna make it work, right? It doesn't matter how we change it, we know that we can change it to make it work. So while what's outside of the window is less than or equal than what we expect, it means we found a potential solution, and we need to then update answer if what we found is less than what is already saved. So trick to do that is to do answer is going to be the minimum of answer itself and the current thing that we found. And remember, we're looking for the smallest size of a window. And to find the size of a window, we usually do this technique here, right minus left plus 1. That's a way for you to find the length of a window given a right and a left pointer. We're gonna update our answer. But notice here that I used a while loop and not an if. That is because we now start the process of shrinking, right? We now want to make sure that we found a potential substring, but it might not be the smallest. So we're going to be shrinking now from the left and see if that's still going to be a valid solution. That's why I use the while here and not an if. So to start the shrinking process here, we're going to simply then add what was in the left back to our dictionary, because now it means it's outside of the window again, and then increment the left pointer. So m of s of left is gonna be incremented by 1 because now it's outside of the window, and m only track things that are outside of the window. And here we increment our pointer by 1. We're gonna be doing this until what's outside is not valid anymore, at which point we exit this while loop and start expanding from the right again. But that should already return here the solution. We return our answer. And yeah, there's one detail here that we gotta make sure the left never goes past right. So just a small detail here, the left must be less or equal than right. Otherwise, we're gonna be doing this while loop here, and left can become greater than the right pointer, which is not possible, right? But that should be already it. Let's see if this works. Let's click on submit. And you see here we beat 71% of the solutions. And time complexity for this is O of n. We have a sliding window algorithm where we're expanding and contracting the window. So we go through our arrays to our array in a linear time. And so, yeah, that's the solution. If you stay to the end, thank you, and I see you next time.